Okay, in this section, we're going to look at some of the applications of quadratic functions. So basically some different types of word problems that you could get. So the first question is: a baseball is hit and follows a parabolic path described by the function h of t equals negative 3t squared plus 12t plus 1, where t is the time in seconds after the ball is hit, and h of t is the height of the ball above the ground in meters. Algebraically determine the maximum height reached by the ball and the time it takes to reach the maximum height. So keywords in this word problem are the maximum height. And you see those words maximum with something, that usually means you're interested in the vertex. So we have the equation in this particular case, so we can just go ahead and find the vertex. This equation is written in standard form, so we can use t equals negative b over 2a to help us find the time, or the x-coordinate of the vertex, and negative b in this case is negative 12 over 2a is 2 times a negative 3, which is negative 12 over negative 6, which is 2. So it takes 2 seconds to reach the maximum height, and the maximum height reached would be the value of height when time is 2, so h of 2. So we're going to fill in 2 for the t, so negative 3 times 2 squared plus 12 times 2 plus 1. So that's going to be 4. 2 squared is 4 times a negative 3 is negative 12 plus 24 plus 1, which is going to be 12 plus 1, or 13 meters. So this is the maximum height reached at 2 seconds. Okay, the next question is another word problem with the equation for the height h in meters above the ground of a projectile at any time t in seconds after the launch is defined by the equation h of t equals negative 4t squared plus 24t plus 5. So again, in this problem, word problem, the equation for the height of the rocket or projectile, whatever it is given to you. So what was the height of the projectile at the launch? So at the launch would mean when time is 0. So you would actually just be solving the equation or to find the value for height when t is 0. So this would be negative 4 times 0 squared plus 24 times 0 plus 5. So these first two terms would just be 0 plus 5, which equals 5 meters. So this is the height at the launch. How many seconds after the launch, question B, how many seconds after the launch is the maximum height reached? Again, you see the keywords maximum with height, keyword maximum. So that means that you're looking for the t coordinate or time coordinate, which is the time coordinate for the vertex if you're looking for the maximum. Because this parabola would open down and the maximum would be at the vertex. So we have t equals negative b over 2a again, which in this case would be negative 24. The b value would be 24, and you want the negative of that, over 2a, which is 2 times a negative 4. So that would be negative 24 over negative 8, which would be 3 seconds. And find the maximum height would be to actually sub in 3, the time that the maximum is reached, into the equation for height, into the equation for height, but we're plugging in t equals 3. So this is t would be 3 squared negative 4 times 3 squared plus 24 times 3 plus 5. So you're just taking the equation for height and plugging 3 in for the t value. So this is going to give you negative 4 times 3 squared is negative 4 times 9, which is negative 36, plus 24 times 3 is 72, plus 5. And that would give you 36 plus 5, or 41 meters. That would be the maximum height reached and at 3 seconds. Question D, find the height of the projectile 3.7 seconds into the launch. So that would mean to just basically take the equation for height and plug in 3.7 for the t value, the time. So it'd be -4 times 3.7 squared plus 24 times 3.7 plus 5. And if you work that out, 3.7 squared times 4, -4, it's going to be -54.76 plus 88.8, 24 times 3.7 plus 5, so put all those together, you're going to get 39.04 meters. So this would be the height at 3.7 seconds into the launch. Okay, the next type of question is a very important type question that you need to know. And these questions a lot of times will show up on your tests or assignments and even exams. So these are the max area type problems. So it says a rectangular enclosure is made using the wall of a barn as one side and 80 meters of fencing in total for the other 3 sides. Algebraically determine the maximum area of the enclosure. So when you're looking for maximum area this time, you don't have the equation, so you have to come up with the equation. So the first step is to look at what they're trying to maximize or minimize. So we're looking for maximum area. So that's what our equation is going to be about. Area of a rectangular shape here. And the important piece of information here is that it's a rectangular enclosure, but they're going to use the wall of the barn as one side. And that's significant because that means your fencing of 80 meters is only going to go on this width, and this length is not going to go along the back side here where the barn is. But we want our equation to be about area because we're looking for the maximum area. So we want area equals length times width. And we can't actually find the vertex of, because when we're looking for maximum or minimum, we're usually looking for the vertex, but we can't find the vertex of an equation written in this form. So what we want to do is go back into the problem and see if we can find a way to relate the length and the width. So the length and the width, in this case, we've got the 2 widths plus the length have to add up to 80 meters of fencing. And that equation is significant because it allows us to rewrite the equation for L so that we get L is 80 minus 2W if we take 2W off both sides of that equation. So that's going to be the equation that we're going to substitute in for L in our area equation, because this is the one that we want to use, the area equation. This is our main equation over here. So we're going to take this and we're going to substitute this, sub this in for L in the area equation. So I tried to erase that, but I can't do it. Okay. All right, so we're going to go back to this area equation. So we now know that area, instead of length, we're going to have 80 minus 2W times W. And most of these rectangular shapes that have 3 sides being used, you'll always be using usually the area, and the length will always be basically the perimeter minus the 2 widths, because they're always usually set up the same way. So then this again doesn't look like one of the forms of an equation that we're used to dealing with when we're dealing with quadratics. So we're going to multiply this W through by both of these terms. So we're going to get 80W minus 2W squared. And then most times we see the equation range with the squared term first, and then so that's a negative 2W squared, sorry, plus 80W. So this is the equation that looks like a standard form of an equation for a quadratic, and it is a quadratic that opens down, so it is going to have a maximum. And instead of an x and y coordinate, we're going to have a W for x. The width is the x coordinate, and A is in the Y spot. So A is the Y coordinate, the area is the Y coordinate. So if we're looking for the maximum area, we're looking for the W, or the X coordinate, that gives us that maximum area. And the W would be negative B over 2A, which would equal negative 80 over 2 times a negative 2. So then that's going to give you negative 80 over negative 4, which is going to give you 20. Looks like 86 there. 80, so it's going to be 20 meters. So that would be the width required to give the maximum area. Now, it doesn't ask me to find the maximum area. Oh, yes, it does. I algebraically determine the maximum area. Sorry, it does. So I can actually plug that W back into my equation over here and get the maximum area. Negative 2 times 20 squared plus 80 times 20. And that's going to be 20 squared is going to be 400 times a negative 2 is going to be negative 800, plus 80 times 20 is 1600. So that gives us 800 meters squared is the maximum area. Now it also asks us to find the dimensions. Well, we know that the width is 20, but the length, we can use this equation right here to give us the length. So the length is 80 minus 2 times 20, which is going to be 80 minus 40, or 40 meters. Try to make that clearer there. So we've got the length is 40 meters. I have a whole lot of room here, sorry. And the width is 20 meters. Those are our dimensions. And the maximum area is 800 meters squared. Okay, so the next problem is a little bit similar to the one we just did, except you only got 2 sides this time, but it's the same kind of basic thought process that goes into coming up with the equation. So it says a gardener bought 30 meters of board to form 2 sides of a carrot garden against a corner in a fenced yard. As shown, if all 30 meters of board is used, write a quadratic function that models the area of the carrot garden and use it to determine the maximum area the garden can have. So again, we're looking for maximum area. So we want our equation to be about the area of a rectangular region, which has a length and a width this time, and that's the only 2 sides that we're going to have fencing or board or whatever, making 2 sides here, because there's already a fence on the other 2 sides. So we want area again is length times width. We cannot find the vertex when it's written in this form, so we look back and see how we can come up with an equation to relate the length and width and make a substitution. And the length plus the width has to add up to 30 meters of board. So that means the length is going to be 30 minus the width. Now you could solve for the W if you want, but I'm going to solve for L. So this is our equation that we're going to sub into area equation. So area is, instead of length times width, is going to be 30 minus width times width. So that's area equals, again, we're going to distribute that W, so that's going to be 30W minus W squared. And if we put the equation in the order of square term first and then your linear term, that's a quadratic that opens down, and it opens down, we know, because there's a negative in front of W squared, and it will have a width for the X coordinate of the vertex, and the Y coordinate is the area. So to find the width at that maximum area value, you use the negative B over 2A formula. And in this case, the negative B value is negative 30 over 2 times A, in this case, is negative 1, because there's just a negative in front of W squared, so that's understood to be negative 1. So that would give you negative 30 over negative 2, which is going to be 15. And this is in meters. So 15 meters would be the width that you would need to get the maximum area. And then to get the maximum area, you can either figure out the length using this formula up here and then go length times width if you want, or you can go back to this area equation and get the area using the width of 15, so negative 15 squared plus 30 times 15. So we're just filling it back in to the area equation that we have over here. So 15 squared, I believe, is 225. So that would be negative 225 plus, and 30 times 15 would be 450. So if you add those two together, you're going to get 225 meters squared for the maximum area. And you're not asked to find the length, but if you were asked to find the length would be this one, using this up here, it'd be 30 minus 15, which would be 15 meters. Okay, so make sure we answered the question. Write a quadratic function which models, so this would be the quadratic function which models the area of the carrot garden, and use it to determine the maximum area that the carrot garden can have, which would be this right here. Okay, now the next two questions, we've decided to omit. We're not going to do the max revenue questions, so we're going to leave those out. And we've got enough word problems there, types to work on. So this here, these are the questions that are assigned at the end of the section. Pages 377, numbers 3AC, 4, 5BC, 6, and there is a worksheet you can get from me.